hello everyone. Have a great day. It's another day and it's another topic to be discussed. So now the topic that I will going to discuss is about edge computing. So allow me to proceed into introduction or allow me to provide a definition. Edge computing is a decentralized computing paradigm that processes data closer to its source, reducing latency and bandwidth usage compared to traditional cloud computing. This means that edge computing is like having a small computer right where the action is happening, rather than sending all the information to a big, faraway computer, which is the cloud. This means it will less waiting time or it will lessen the waiting time, which is the latency, and less internet traffic or the bandwidth, making things faster and more efficient. So now let us proceed into the key concepts of the edge computing. First, we have the proximity to data source. Second, decentralized architecture. The third one is the real-time processing. The fourth one is the bandwidth efficiency. Fifth is the scalability, but we will first discuss this one by one. We will proceed into first one, which is the proximity to data source. Proximity to data source, edge computing operates near data sources, minimizing data transfer distances. Edge computing is like having a mini computer close to where the data is generated. So this means it is right where the action is happening, like in a factory or in a device. By being nearby, it doesn't have to send the data far away to be processed, which saves time and make things work faster. So now we will go into the second one, which is the decentralized architecture. It utilizes distributed nodes for data processing rather than relying solely on centralized data centers. So decentralized architecture spreads data processing across many locations, and instead of relying on one central place, it is like organizing a library by distributing books to many people instead of one person, doing it all in one room. This makes the system more efficient and resilient. The third one, the real-time processing, enable quick data analysis and decision-making crucial for applications like autonomous vehicles and industrial automation. So as real-time processing allows for fast analysis of data and quick decision-making, it is essential for applications such as autonomous vehicles and industrial automation, where split-second decisions can be critical for safety and efficiency. We will go into the fourth one, which is the bandwidth efficiency. Reduces the need for data transmission to centralized servers, optimizing bandwidth usage. Bandwidth efficiency minimizes the amount of data that needs to be sent to the centralized servers, which helps optimize bandwidth usage. It is like finding the most efficient route for delivering packages, reducing congestion, and maximizing the capacity of the network. So we will go now into the last but not the least, the scalability. Allows horizontal scaling, adding more edge nodes as required, ensuring flexibility and resource allocation. So scalability means you can easily somehow expand by adding more edge nodes when needed. So you could able to add edges as much as you needed. So scalability means you can easily expand by adding more edge nodes when needed. So you could able to somehow expand or add more edges as much as you need it, providing flexibility in managing resources. So it is like adding more disk to a workspace as your team grows, ensuring that the system can handle increased demands smoothly. So we will proceed now, or we will go into the application. The first one is the IoT, or the Internet of Things. Facilitates real-time analysis and decision-making for IoT, or the Internet of Things devices in smart cities and healthcare. So for IoT, or Internet of Things, which are devices like smart sensors and gadgets, edge computing lets them make quick decisions without waiting for instructions from far away. This is super useful or very advantage or has a great advantages in places like smart cities and healthcare, where split-second decisions matter, like detecting traffic patterns or monitoring patient health in real time. The second one, which is the autonomous vehicles, enables immediate data processing for safety critical decisions. So, in edge computing plays a crucial role in autonomous vehicles by processing data instantly for safety critical decisions. So, instead of waiting for data to travel to a central system, edge computing allows vehicle to analyze information on the spot, or you could able to analyze information right away. So, helping them react swiftly to changing road conditions and potential hazards. This real-time processing is somehow essential for ensuring the safety and reliability of autonomous driving systems. So the third one, retail and customer engagement, supports real-time customer behavior analysis and personalized experiences. So in retail, this means putting small, powerful computers in stores. They help analyze what customers are doing right away. So stores can offer personalized experiences and understand how customers behave in real time. So let's say for example, they can suggest product based on what you're looking at or offer discounts on items that match your interest or the items that you are desired with. This makes shopping more convenient and customized to each customer's preferences. The fourth one is the telecommunication, enhances low latency application like video streaming and gaming. So in telecommunication, this means having faster access to things like video streaming and gaming. So edge computing helps make things like watching videos and playing games smoother and faster with less delay. So the fifth one is the industrial automation, enables real-time monitoring and optimization of manufacturing processes. This means that instead of sending data to a distant server for analysis, the data is processed right where it is generated, enabling quicker responses and more efficient operation in factories and production lines. So we will go now into the challenges and considerations within the edge computing. So first one would be the security, resource constraints, interoperability, and data management. But we will discuss that as well one by one. We will proceed into the first one, which is the security. Security ensuring data privacy and protection against cyber threats. So security is as a major concern in edge computing as it requires ensuring data privacy and protection against cyber threats and like unauthorized access or breaches. This involves implementing encryption, authentication, and even the strong cybersecurity measure to safeguard sensitive information throughout the process. The next challenge or consideration would be the resource constraints. Optimizing resource utilization in devices with limited computational capabilities. One big challenge as well is making sure these devices can handle their tasks efficiently despite their limitations. This means finding ways to use their resources wisely so they can perform their functions effectively without running out of memory or even processing power. So, in simpler terms, it's about making the most out of what they've got to work with. The third one is the interoperability, integrating diverse edge devices and platforms seamlessly. In edge computing, interoperability is also a challenge. It is like ensuring that different devices and platforms speak the same language to work together smoothly. Just as diverse language can make communication difficult. Various edge devices may use different protocols or systems, making integration a challenge. So achieving interoperability means making sure these devices understand each other to operate effectively as a team. The last one would be the data management, implementing strong strategy for data storage, synchronization, and consistency. As managing data efficiently is crucial in edge computing, this involves ensuring data storage is optimized, synchronization between devices and central system must be seamless, and data consistency is maintained across the network. These aspects are fundamental for reliable and efficient operation in edge computing environments. Now we will go into the future trends. Number one would be the edge AI, which is the integration of AI algorithms for intelligent decision making at the network edge. Imagine that you have a smart device like a phone or a camera. Instead of sending all the data to a central server far away, Edge AI allow these devices to process the data and make decision right there on the device itself. This speeds up decision making and reduces the need for constant internet connection. So Edge AI is all about making devices smarter and more efficient by letting them think and act on their own, right where they are. The second one is the fog computing, introducing intermediate layers for hierarchical data processing and distributed intelligence. Fog computing is also one of the future trends in edge computing. Fog computing acts as a mediator between your device and the cloud, processing data closer to your device before sending only important information to the distant cloud server. It's like a smart filter that speed up processes and improve efficiency by analyzing data locally or in nearby servers. This method is ideal for tasks needing rapid responses and distributed intelligence, enhancing the responsiveness of system for the future. The third one is the 5G and edge computing, leveraging ultra low latency and high bandwidth connectivity for diverse applications. In the future, edge computing, which processes data closer to where it is generated, will benefit from 5G technology. 5G's high speed, low latency connectivity will enable diverse applications like real time gaming, augmented reality, and seamless video streaming, making edge computing even more efficient and powerful. We will proceed into the last but not the least, edge to cloud integration, combining edge computing with centralized cloud infrastructure for seamless data flow and scalability. Edge to cloud integration combines local data processing or the edge computing with the vast resources of remote data center or which is the cloud computing. It is like having a smart helper close by or edge who can also access to a huge library which is the cloud for more information when needed. This setup ensures quick responses and easy scalability for handling data effectively. So here's the takeaway or the notes to remember. Edge computing offers a significant advantages in terms of latency reduction, bandwidth optimization, and real-time processing, making it pivotal to various industries. Addressing security and interoperability and resource constraints will be crucial for widespread adoption and integration into future technological ecosystems. So, in short, edge computing is like having mini data centers closer to where you need them rather than far away. It helps reduce delays, save internet space, and quickly handle information as it happens. It is super important or has an advantage for many industries. However, for it to be used everywhere, we need to make sure it is safe, works well with different systems, and doesn't use up too many resources. So that would be all about edge computing.